Bismillahirrahmanirrahim. Assalamualaikum dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Kuwait University of Science and Technology. Today we will take lecture number 24 of the subject of software engineering, in which we will discuss software testing. In this lecture we are going to discuss the types of software testing and also the introduction about the software testing. Software testing is in fact very much exhaustive topic. It's very much complicated and also it's very much technical. So that's why I'm going to discuss this topic in very much detail. So hence we require 3 lectures. So after these lectures we are going to deliver another 2 lectures, so that we must be able to perform the complete testing on the software product. This is the discussion agenda. The discussion agenda contains what is the software testing, verification and validation of the testing, types of testing and testing priorities, test data and test cases, design of test cases. Now, testing. Respected students, you can take material from the chapter number 23 of the IM book. So kindly I suggest that you should read this chapter very much thoroughly, so that you may get complete idea. But this lecture is also very much complete, so I hope that you will get all sufficient information from this lecture. What is software testing? Basically, software testing is a huge process to evaluate functionality of the software application, with intent to find whether the developed software meet the specified requirements or not, and to identify the defects to ensure that the product is defect-free in order to produce the quality product. Basically, software testing is a process. Software testing is like another software development process. It is by itself is a process. The purpose of the testing is to evaluate the functionality of the software, which is intended in the SRS. So basically the purpose is to find out that whether the software is performing according to the requirements or not. If the software has some defects, so then we identify the defects in the software testing, and then we inform to the developers that the particular components has defects. So then the developers re-implement the particular component and then retesting is performed. Basically, the purpose of testing is to ensure the quality, to ensure that the best quality has been achieved for the product. Now, there are 2 concepts in testing called verification and validation. Both ensures that the software system meets the user needs. So, for example, when a system is completely developed, then we verify and validate that the software is according to the software requirement specification document or not. Then we say that the software has a good quality and it meets the specification. Now, what is the verification and validation? Verification says that are we building the product right, and the software should conform to its specification. Basically, verification is a process in which we verify the functionality of the system with the requirements. That we verify that this functionality is already has been spotted out by the customers or not. So if the system is performing well, so we say that all the SRS is traced here in the product. So this means that software is completely verified according to the SRS and is functioning completely according to the user expectation. Now, validation. Validation is a little bit different than the verification. So validation says that are we building the right product? Basically, validation is performed by the developers. So the developers, with each implementation, he or she does the validation test. The validation test says that the software should do what the user requires correctly. So verification is the conformance with the SRS, but the validation is the conformance with the user according to the product. So validation is in fact the post-development test, and verification is in fact the pre-development test. So we should verify that the developer is performing according to the SRS, then it is called the verification. And validation means that the product is, in fact, when the product has been completely developed, then we says that to validate the product. So it is exactly like that. When we take interview from the candidate, we validate his or her abilities, and verification is exactly like that. When we take the resumes from the candidates, so we verify that these resumes are according to the particular university or particular higher education commission. So we verify the document. Verification says that this document is in fact legal and also it's the original. So we says that it is verified. But validate means that when we perform the testing and it gives us certain results, so we validated the software. Okay, now it is very much important to discuss the types of testings. We have many types of testings. The most important are here. The first one is called the unit testing. Unit testing means that when the software is developed unit by unit or piece of code by piece of code or by module, then we says that it is the unit test. And then if we test the particular module or the code or the particular functionalities, then we say that we have tested the particular unit. For example, in the websites there are many units, there are many sub pages. So any one is a unit. For example, searching of query is one unit, insertion query is the second unit, deletion query is the third unit, and similarly update query is the fourth unit. So we in fact specified different units here. So example is that in a program we are checking if loop method or function is working fine. So every program contains multiple functionalities, multiple units. So each and every unit here we test, so it is called the unit testing. So basically testing is performed here by providing the input to the systems and the system provides us the output, and then we confirm that whether this input output is matching according to the SRS or whether it is matching with the test cases which are developed by the SQE. So software quality assurance employee, basically they design the test cases and then we confirm that these test cases are being achieved by the product. Okay. Similarly, another example we have misunderstood of incorrect arithmetic precedence. For example, there is certain formula or for particular increment or decrement operations or certain addition, subtraction, multiplication, division or another operations in the particular expression. Then we, for example, set a test here, the precisions here, then it is also called a unit test. Similarly, incorrect initialization is also a unit. Incorrect initialization is one line of code. So we test here particular line of code that it has been initialized according to the needs or according to the designs of the software. Another testing strategy is called integration testing. Integration testing is basically a test which we fix when we perform when we integrate the different components with each other, and then we test that the integration has been performed according to the expectation of the user, or the data is basically handled very well in a good fashion, or the data is passing between different components. So the objective is to take the unit test components and to build a program structure that has been dictated by the design. Basically, integration testing is a testing in which a group of components are combined with each other to produce the final product and the output. So then we test that properly they are integrated with each other. For example, if I want to send an email, so then I click on the send button, then the email is sent. But also another component here is called, that is the outbox. So I can also check the email in the outbox. So in the outbox unit, all the sent emails are stored there in the outbox. So I will check here, they are in the outbox. So outbox is properly integrated with the send email functionality. So I will check that if I send email, this email should also be in the outbox. So this is the example of the integration testing. In integration testing, we have different types: top-down integration, bottom-up integration, sandwich integration, and big bang integration. Okay, in top-down integration, we integrate the components from top to bottom manner. For example, the topmost are the parent components first integrated, and then their child, and then their subchild, and so on. And then we test the system according to the top-down fashion. And the bottom-up integration, when we test the software, so first we test integrate the child or the leads classes, then we integrate their child, and then their parents, and so on, and finally the top parent. In the sandwich integration, we in fact act as like the sandwich. So in the bottom-up testing, we in fact integrate the different components in the bottom-up styles. That first of all, leaf components are integrated with each other, and then their parents, and so on, and at the last we integrate and test the final, which is the top parents components. In the sandwich integration, we in fact test this software with the both approaches, top down and bottom up. Basically, sandwich gives us the advantages of both top down and bottom up approach. So sandwich is the combination of top down and bottom up approach both, and thus sandwich is more better testing than top down and bottom up approach. In the big bang integration testing, basically all the components are completely once developed, then they are integrated with each other, and then the system is tested, and after which is the final test. And then after the final software, when it is tested, then each and every component is tested also in isolation. So big bang is in fact done after the complete test, which is called the system testing. Okay, next type of testing is called regression testing. Regression testing is in fact a testing which in every time when a new module is added to the existing system, then the system is tested so that it's properly the new module is properly working with the existing modules. So that is called regression testing. So it is a test when a module is added to lead to changes in the program, and this makes sure that the components work properly even after adding components to the complete program. So in fact, mostly regression testing is performed in the maintenance phase, or when the software is evaluation phase. So evaluation is in fact evaluation is that phase in which the software evolves. Evolves means that the change management in the software is occurring. So that types of testing is called regression testing. Example of regression testing is this one, that in the school record system that we have a module called staff, students and finance, which are combined with each other. So these modules are checked in, and if on integration these modules works fine in the regression testing. So and when three different modules are combined or integrated with each other, then the system is tested again. So that is called integration testing of the regression testing. Okay, another type of testing is called smoke testing. Okay, this test is done to make sure that the software is testing is ready or stable for further testing. It is called smoke test as testing initial pass is done to check if it did not catch the fire or smoke in the initial switch on. So basically the smoke test is that test which we perform initially. So for example, if we do certain sort of the input the incorrect input to the system, then we say that whether it is passing the smoke test or not. So first of all, we will provide some incorrect input to the system, and when the system behaves accordingly to the SRS or it is behaving very well, so then we will perform another testing. The smoke test is also always it is performed on the false data. So this is very much important test. Example of the smoke test is if a project has two modules. So before going to module, make sure that module works properly. So if for example two different modules, so first of all, first module has been developed, so then we will test it, and then we will develop the second module, and so that the first module is working properly. If the first module is not working and the second module we have developed, then we will test both of them. So that's why the smoke test is that test which is very much initial test. Immediately after that we test the system. Another is called alpha test. This type of validation testing, it is also called the validation testing. It is the types of acceptance testing which is done before the product is released to a customer. It is typically done by quality assurance people. So basically alpha test is that test which is in fact performed by the developer itself. And beta test is in that test which is performed by the customers. For example, often we talk about the beta test or the beta version. So alpha test is the test which is performed by the developer before it has been tested by the customer. Okay. The example is when software testing is performed internally within the organization, then it is called the alpha test. Beta test. Beta test is a test conducted at one or more customer sites by the end user of the software. The version is released for the limited number of users for testing in a real-time environment. Basically, the beta test is that test when a customer performs test by itself. So that is called beta test. Often we in fact have seen that the beta version of the software, beta version is that version which is provided to the customer so that the customer can identify the defects in the system. And if they identify the defects, then we perform the maintenance and the another version of the software as it should be launched. So this version is released for the limited number of users for testing in a real-time environment. The example of the beta test, when a software testing is performed for a limited number of people, then it is called the beta test. Mostly the beta test is in fact performed by the people who are using the software. So if they says that it's okay, then the final version is launched. And the beta version is actually, there is incomplete version with the all functionalities but with the limited designs. The design of the GUI is not actually that we don't final the software system by the GUI. So then the beta testing is where we have performed the beta testing. Next one is the system testing. System testing is that test which is performed when the final system should be that is delivered to the user. So that is called the system testing. In system testing, all the modules are properly integrated and they are tested as a whole. So in this we focus on the required input and output without focusing on the internal working. So basically system testing is that test when the full software is available with us and then we test the system. So in this way we have the security testing, recovery testing, stress testing and performance testing as well. Security testing is that testing which we perform for the data security or information security. Recovery testing is that test when we perform it so that the software recovers itself from the failure or it recovers the data. And stress test is that test when we test the system for the stress. For example, the system is accepting particular number of users online, then we say that it takes the stress of, for example, 1 million users simultaneously. And performance test is that test which is also called the speed test. Also, it tests the software performance, that particular number of transactions should be performed in the unit time. Okay, the example of the system testing is that includes functional as well as all non-functional testing. All the functional requirements and non-functional requirements are tested in the system testing. And finally, we have the stress testing. In number 8, we have the stress test. In stress test, we in fact give some unfavorable condition to the system and checks how they perform in these unfavorable conditions. For example, if a particular server accepts only 1000 users simultaneously and we give 2000 users, then we are going to test the stress test of the system. So we are stressing the softwares basically. So we will test that whether in a particular environment the system is working fine or not. Okay, the example of the stress test is okay. The example is test cases that require maximum memory of other resources are executed. So, for example, when we are performing certain operation which requires the maximum memory, so then we are testing the system for stress. Test cases that may cause crashing in a virtual operating system. For example, there is a virtual operating system and the system is behaving some abnormally. So that's we are going to test the stress test of the system. Test cases that may cause excessive disk requirement. For example, there is 50 GB required disk storage for the system, and if we have less than 50 GB, so we will test that whether the system is still operating or not. So that is called a stress test. Now last one is the performance test. Performance test is the test which we test the software at runtime for the performance of the system. Basically, the context of the integrated system, it is used to test the speed and effectiveness of the program. That whether the system is performing the particular functionalities or the group of functionality in a specified number of unit of time. So basically, when we test the system for the speed or number of unit executed per unit time, then it is called the performance test. Measuring number of processor cycles is also the example of performance test. Now testing priorities. So basically we sometimes prioritize the test. So we want to test the exhaustive testing, but we are prioritizing for the take the priority for the certain inputs. So test should be exercised as system capabilities rather than its components. So testing old capabilities is more important than testing new capabilities. So we should also test the old as well as new as well. So sometimes when we have the new capability or new increments in the system, so then we should also test the old system, because it may be possible that there is certain interface problems. So that's why testing priorities should be given to all components. Okay, testing typical situation is more important. Basically, okay, the test data and test cases. It is very much important that how to design the best test data and test cases. The test data is certain input which are devised to test the system. For example, there is a program which performs the square root. For example, square root of 100 is 10. So 100 is the test data for the square root function. The test cases is including input as well, and also the output of the system. Basically, test cases include all the inputs and outputs for this particular operation performed by this system. So test cases is in fact including the test data as well. Now, designs of the test cases. Exhaustive testing strategy must be used for designing the test cases, so that it should test all the conditions and operators of the systems. Basically, we have large amount of operations in the system, so we must have to design certain test case which can test the full software. Therefore, we must design an optional test suites that is the reasonable size and can cover as many errors existing in the system as possible. Now, this is the example of a certain programming language. For example, if x is greater than y, it means that one number is greater than the second number. Maximum is x, else maximum is x also. You can clearly see there is the error. For example, it should be if x is greater than y, maximum should be x, else maximum should be y. But no, how the software quality assurance employee can design the test cases to test that or detect that error. For example, the above code segment the test suites 3.2 and 2.3 can detect the error. For example, 3.2 cannot detect the error, but 2.3 can detect the error. For example, 3.2 in which first number is greater than the second number, so maximum is 3. But in the case of 2.3, if the first number is not greater than the second number, it is false. So maximum is again 2. So which is in fact not correct. So hence it detects the error here. For example, it detects here that 2 is not greater than 3. So that's why the system will say that maximum is 2, which is incorrect. But another larger test case 3.24351 cannot detect the error because the first number is always greater than the second number. Here, first number is greater than the second and the first number is greater than the second. So else part is not executing for this test cases. So that's why we should carefully design the test case. Okay, this implies that the test suite should be carefully designed. Then taking random, therefore systematic approach should be followed to design an optimal test suites. So that's why optimal test suites is that one which has both the values, the greater than or equal and the less than or equal, and should also be equal values as well. For example, if there is the equal operator, should also be, for example, 4. So that's why good test cases should test the every branch of the code. Okay, respected student, this is the end of the lecture. So if you have any question, you can send your email to me. My email is in the footer section of the slide. So m.kadim@kust.edu.pk is my email. So if you want to read these topics, so you can use these books. There are the references of the books. So if you want to further explore the topics, you can also read another resources as well. Thank you very much.